Welcome to the fourth chapter. So you've done a lot of work up to this point, and it's about to get really interesting because what we're going to do is work our way towards creating something like this, a teapot. And the teapot, I know it's cylindrical, but only the body is, and everything else tends to involve curves and we can do lofting and extrusions and there's conversions. There's all this whole other set of tools in Maya with surface work that really is, in my opinion, fantastic. It's the sort of old way of modeling, the predecessor to polygons that I think a lot of new modelers, novice modelers don't know about, or they're afraid of, or there's maybe just not enough information on it, or they don't know how to utilize it. And I have found that in this program, if you don't know how to use surfaces, then you're missing about 50% of what you can do in modeling. Even though the ultimate goal is to convert everything back to polygons, we will use surfaces and curves to get to that final quality look that we're trying to achieve. So this teapot is an example of what I've done in several semesters over the years, and I make that one every semester. I've gotten pretty good at it. This time around for the videos, I'm not going to make this one. I'm actually going to sketch one out myself and come up with a design of my own and make a brand new one. And it will have some similar details that this one has because I do enjoy this spiraling bamboo wrap. There's a lot of interesting problems to solve on that. And let's get right to it. And let's start with curves and the curve components. So let's start with curve components, understanding curve components and where our curves live in Maya. There's a shelf right here called curves, and that is a circle, a square, the EP curve, pencil curve, and a couple other basic curve editing tools. I rarely use the shelf, maybe just to grab the circle primitive. I normally use the CV curve tool, and CV stands for control vertex. So just so that you can see that, I'll click some basic curve. And when I right click on this curve, control vertex, that's what CV stands for, CV right there. EP curve, which is the one below it, that one, the EP, stands for edit point. An edit point is the actual crosshair right here, this actual target that lives on the path, whereas CV is the tangent handle of the path. That's what, when editing CVs, you're doing. You're actually editing the tangent handle of the curve. So why use one or the other? Because for one simple reason, CV, I use that almost all the time for solving modeling and rigging problems. EP, I would use only when I need to closely and accurately trace an image. So back to this wood dowel illustration, if I wanted to follow my illustration exactly, where I lay down the points is exactly where the curve will go. And I'll hit enter to finish that, so I can get it right on top of the drawing without having to further come in here and edit points. I can just get it on a single click. The CV curve, on the other hand, where you click is not where the curve appears. So you can see how the curve has been kind of tucked underneath. So kind of like a subdivision surface where you need to kind of yank on those points a little bit to get that subdivision surface to get to the actual volume that you're trying to achieve. That's why the EP curve is useful for tracing images. For all else, I use the CV because it just seems to solve problems very well, and I don't get any extra points. So that's another interesting thing about EP, is that I get these extra points that I may not necessarily need, and the CV is nice because I can limit it to exactly 4 points to draw a curve. It takes 4 to create a curve. Let's just get this new scene open up and let's investigate the CV curve components. Oh, here's the Bezier. Before I do that, here's the Bezier for those of you who are coming from Illustrator, and the pencil, which is basically click and draw. It creates an awful lot of points, but that may be a solution that you need. It's good to know that it's available. Also, you have these arc tools, which does these very simple and very interesting calculations, which I barely use. You have that stuff too. Let's see here, measurement tools, which involve using a simple curve, although I don't really need those. Text are curve-based, and then anything you import from Illustrator in terms of EPS, objects.eps, I think is what it is from Illustrator, that would be just come in as a series of curves. So back to CV. Let's go to the top view and click out a few points for us to investigate. So you can see that when I first create this, like I said, it takes 4 points, the first 4 to actually generate a curve, and then any more is just whatever you need to get the job done. So you have to have at least 4. Notice that there's a U right here. That U is represents the U value of this surface. So surfaces are measured in UV space. So that would be like a 0 to 1 value. So when I hit enter to finish this curve it starts at 0 at this first CV, and I know this is the first CV because the U is on this end, so that's the first CV, and that the last CV is a value of 1. Everything else in between is a scalar value between 0 to 1. Knowing that really helps you out when you get to the point where you start using curves for rigging, and you start using curves to solve some very sophisticated modeling problems like creating organic structures, maybe even organic structures such as the shell to a car or a motorcycle or a boat or things of that sort. When you're manipulating the curve, it's much like polygons. All you have to do is right click on the curve and you get a few options. CV we've investigated, EP edit points we've investigated. Curve point is a bit of a mystery for those of you who use this for the first time. You get pretty much nothing available except when you click on the curve, and you end up with this. What's happening is you're choosing an arbitrary location on that path. So you're choosing an arbitrary U location on that path, and I can hold shift to select multiple arbitrary locations on this path. Why do that? Well, because let's say I wanted to cut this curve into many subcurves. I could declare all of those points and then come over here to my curve menu set or my surfaces menu set. And you can see right here is an edit curves menu. So here are all the tools you're going to need to edit curves with. And I can detach the curve at all of those defined curve points. So now if I take a look at my outliner, I've got all of these additional curves, each with a minimum of 4 points or more to generate that curve. So it's pretty handy. You want to keep that one in mind. The CV, or I'm sorry, the CP or the curve point is very, very useful. Object mode, you know what that is. And Hull is just the ability to see and visualize the direction of the tangent handles, and you can manipulate this. There may be some tool somewhere that utilizes the Hull, but I haven't run into it yet. So let's delete that. Let's look at the components of surfaces. So a surface, and let's bring in a plane, is just a two-dimensional version of a curve. So if I go to the channel box and the inputs and I enter UV patches of 5, let's say, I can add divisions to this patch. And this patch starts at a value of, and you can see here I've got control vertex, and you can see right here I've got the U value. It starts at 0, 0, and here's the V value, That's the vertical. If you can't remember which direction V is, just remember it's always the vertical direction. So it's got these U, V, and for every starting point along the perimeter of this patch, you've got a tangent handle. So just keep that in mind. There's always this extra set of points right here that control the curvature on that tangent handle. So you can see it's by default, without having to deal with any kind of subdivision surface or anything of that sort, it's organic. So I can grab these, and as you would imagine, it's just a series, it's a matrix of curves. Okay, so what else does a surface have? A surface also has isoparms, which are very important. These are, again, both actual edges. We'll call them edges so that you can compare them. They're called isoparms, but let's just compare them to edges. So they're like the edges for a surface, and I can not manipulate them. I can't translate them. I cannot rotate them. I cannot scale them. What I can do is manipulate, rotate, translate the control vertices. So that's how you manipulate the surface. So what's the big deal? Why would I want to edit the isoparm? Because what I can do is run functions like loft from this surface to another surface via an isoparm. So if I had a duplicate of this surface, Control D, I could loft from this isoparm to that isoparm using this menu right here, surface and then loft. And now I've got a connection between two surfaces. And it's all like this real-time quality stuff. It's really nice. In that loft, I can give divisions, so that it's relatively curvy. And then that loft, I could then manipulate further to do whatever I need to do to it. Maybe something like that. Use soft selections on it. What else does the surface have? The surface also has surface points, which is just another way of saying give me an arbitrary location on the surface, and then I can do something to that. Maybe add another isoparm, or attach an object, or constrain something to that location. The hull is, again, similar to the hull of a subdivision surface or the hull of a curve. And I can manipulate, in this case, I'm almost certain I can manipulate almost on a per edge basis on the hull. Yes, there you go. So on the hull on a surface, you can manipulate by simply clicking and dragging over one edge of the hull and be able to manipulate it like that. So there's another fantastic way to manipulate the edges of a surface. And surface patch is just a way of finding that section in the UV space, which is defined within the boundaries of isoparms. So it's kind of like selecting the surface normal on a polygon. We can't select surface normals on a polygon, but this is sort of like that. That kind of sort of gives you an introduction to what the different parts and pieces are to curves and surfaces. The next step for me is to show you how to do things such as construct and cut and split and manipulate and extend and offset and do all these interesting things to curves so that you can create your own custom primitives, your own custom patterns. So we'll do that next. Okay, so in this section we're going to cover curve editing, and there's a few tools that I want to spend time and focus on. That would be extending, cutting, attaching, offsetting, and inserting. Inserting knots, that is. So let's go over those in particular. So I'll draw a CV curve in the top view. Hit enter to finish it. And let's just tear off this menu, the Edit Curves menu, to do this work. So the first one, cutting curves, it's pretty straightforward. All you need are two curves. So let's get a primitive circle for this. And I could cut this circle any way that I need to by simply overlapping it with another curve. So I could get a brand new shape here by overlapping, say, this circle with that particular object. So let's go to object mode and select both objects and hit the cut curve option. And right away we get these bits and pieces here, and then I could take that shape or this new shape and combine it into another curve. To combine these curves together, that's the Attach Curves tool. The Attach Curves tool has two features inside of it that are really important. So open up the option box for that. That's Connect and Blend. Also this Keep Originals, which is more common in all of the other tools. So you want to keep track of if Keep Originals is on by default. In this tool, it is on by default. And Keep Originals will simply keep the original curves while creating a new one, and that will make a larger stack in your outliner as you continue to edit your curve. So just keep track of it, and as you create curves, you may want to name them uniquely so that you know which one's which as your list gets longer, and that becomes more important on the teapot, which we'll see soon. So connecting between these three curves, if I use the connect option, I get a very sharp, clean, kind of what you see is what you get connection. So it tries to preserve that transition in a very sharp manner. So that's generally what I like to use. Another option, and notice it's highlighted in purple, so it's still connected to the original. That's good to know. Another good use of Keep Originals. Blend. Let's see what that does. So it does what you would imagine. It tries to kind of smooth out that transition and gives you a slightly different result. So depending on what it is you're trying to achieve, Connect and Blend giving you sharp and smooth results. So that's what you really need to know. Next on the list of very important curve tools is Insert Knot. So using this curve here, inserting knots is a way of saying add more points or add more CVs to the curve. So inserting knots, let's open up the option box for that and just tuck it over here for a second. Inside there are two options. One is at selection, which I believe is the default. It is at selection and between selections. So those are the two really important pieces. Notice we do have an option for keep original. If you wanted to, you could keep the original curve and have the new one with all the added points. By default, that is turned off because I imagine most of the time you don't. So it works like this. I can define a curve point, which is an arbitrary location on the path, and I can hold shift and define multiple points in which to add CVs. So I can have CVs at those exact locations using the insert location with at selection, and when I hit apply, I get CVs at those locations. I also have the option to use curve point and define a range. So I can say between this selection and that selection, insert a number of knots, and I could say give me 7 between those two selections. So you could easily increase the density of points on your curve without changing the shape of the curve. And that's what's really important about this tool. It preserves the contours, the shape of your curve while adding the additional CVs. It's very useful, very nice. Very nice when you want to have a particular shape and then really pump up its point density so that you can then run dynamics on it, and that would be, getting into rigging and animation, but it's very useful to know. Another way to use this tool is to simply run it on the entire object in object mode. So let's say I have another curve and I decide I want this to be a much denser in point count. So I can, with it in object mode, for the entire object, it will, between selections, insert a number of knots. So let's give it, say, 10 new knots evenly distributed across the entire length of the curve. It's pretty nice. And then let's look at a linear version right here under the option box for curve CV and draw a 2-point linear curve. So let's say you wanted a straight line, but then you wanted to, like I said earlier, add more points to do something dynamic to it. Again, between these 2 points in space, we can easily and quickly evenly distribute knots along that length. This may also be useful if you were, say, making a spine for a character, or you wanted to add like roll objects in the forearm for a character or in the thigh. This could easily make evenly distributed points for you to then attach objects, control objects, and then deform a character based on it. So that's another useful application of the insert knots. Extending. Extending is very important. I'll just use this curve for that example. Let's open up the option box for extend. And in here, really the most important thing that I can see, and let me just reset this. By default, it wants to extend the end of the curve. So similar to when you're drawing a curve, you're always drawing towards the end of the curve, whereas the start stays right where it is. And I have options. I could reverse the curve direction to draw this way. So I could come in here and hit this reverse curve direction. So now the U value is there, and then I could continue drawing this way by using the add points tool and continue to add points to that. So there's options there for like just flipping it around. But extend is nice, and I've had scenarios where this is very useful, where you have like a very rigid, geometrically perfect curve, and you simply want to add a bit of length to the ends, either the start or the end or both. So if you were to choose the both option, it will give a new distance of 1 and push both outward, giving you divisions as it goes. That's very, very, very useful. So let's say I had a circle, for example, and the circle is very nice because it has this feature in it called sweep. I could increase or decrease the sweep to 180 degrees, which opens it up into a half circle. But notice it preserves the number of CVs, so I still have the same number of CVs. And I can easily increase or decrease the number of sections on this circle while animating the sweep. So you could come up with some very interesting animations with that alone. But with the extend tool, I'm able to get like a nice arc and then maybe some columnar lines going underneath it. So let's say I rotate this 90 degrees, maybe negative 90, so it's pointing down, and then I extend it on both ends. So I'm just going to pop that forward. And so this could be a very convenient, easy use for, you imagine that's some kind of window or some kind of archway, or the teapot that I've made in the past, the handle to the teapot. It's a very useful tool. The next one is offset, and this one is I find particularly good because you can create perimeter curves, parallel curves that perfectly match the shape of your neighboring curve. So let's just show it in action. Offset curve, almost the same as offset for in the extrusion, polygon extrusion offset. Actually, it is the same thing. So let's just use the defaults. So what happened here is that this distance right here is just a little too large, so I'm going to decrease that distance. There we go. And you can get a sense of what's happening here. So it's giving you a perfect parallel spacer from one edge to one curve to another. And notice that the first curve is still in charge, because this one's highlighted in purple, so we've got an input-output connection between each. So if I make a change to this one, notice how the other one will preserve and dynamically change its point count in order to keep this shape, to try and follow that shape. That's very, very useful. And I can also use a negative number to go to the opposite side. So I don't have to always use a positive number. I can pop to the other side as well. And if you're feeling a little clever, you could stack a couple of these. I don't really have a reason right now for doing this, but I thought, well, if you needed to, you could manipulate all of them all at once by stacking one on top of another, so they propagate from one to the next. So that could be useful. Okay, something to consider. I mentioned detach earlier. Let's get a basic circle for that. Detach is this guy right here, and I will define a curve point, and maybe a couple, maybe two. And with those two selected, I can hit the detach button, and it will separate that curve into its individual pieces. And let me flip to perspective view to see this thing. And then I could take this shape and hit open or close this curve. You may need something like that. So in review, attaching, very important. Detaching, cutting curves, where you overlay curves on top of curves. Inserting knots, many uses for that. Extending, offsetting, reversing the curve direction for certain scenarios to fix certain problems. And then I did show the add points tool for continuing to draw an existing curve. There's one more I would share with you. That's this one right at the top, duplicate surface curve. That one is kind of important. I think maybe very important. If I had a surface and I had a few divisions on this surface, and then I maybe change the shape of the surface, something like that, I could then pull any isoparm anywhere on this surface, like that one for example, or maybe this arbitrary location for example, and I could hit this duplicate surface curve option, and it will generate a curve based on that. So it's very, very, very useful. And then I could do all sorts of interesting things with that because it still matches to the ground. So if I were animating or deforming the ground in some way, or this grid in some way, that curve will match it. And of course I can assign objects to the curve, so then the object would follow the surface as well. So there's some interesting rigging opportunities there. This also works on a polygon object with a little caveat. So let's get just a sphere, for example. And we'll select an edge selection, say from there to, just not clicking, there we go. Just wasn't clicking correctly. And I hit the duplicate surface curve. It does generate a curve based on each edge. And notice that what it does uniquely different with polygon object is it builds one curve per edge. There may be some use for that somewhere. I haven't found it yet, but I think it's good to know this. It's also good to know this, that if you wanted one curve, not 4 curves, generated from this selection, you could then take those 4 and attach them, and maybe even with the blend option, and we won't keep the originals, and I'll just hit the attach button. It'll blow away the old ones and leave me with this new one. So now I sort of have, I'll turn on wireframe here. Now I sort of have a curve. Well, not sort of. I do have a curve that follows and matches that that surface. And it does seem to have its parts and pieces still. It's a little disappointing. Take a little bit of practice. Try it out for yourself. See if it's any good for you. Duplicating surface curves works perfectly on surfaces, as we saw. Does work on polygon objects, but I think it would take a little finessing. So onto the surface menu. Um, I'm only going to cover, I think, 3 pieces in that. The ones I'm really interested in are revolve, loft, and extrude. Maybe a 4th distant interest in boundary, and I'll share those with you right now. So let me just make a new scene, and I'll go to my front view and exhibit what revolve can do. So I'll create a CV curve, and I'll snap to the grid starting at the origin, and I'll work my way out here a bit. Oh, it's still set to linear. Let me reset that back to 3 cubic. Okay, something a little bit more organic. And I'll give you the classic wine glass that you may or may not be familiar with, or maybe a martini glass or something. Yeah, something like that. So, popping back to the perspective view, you can see I have a flat curve, and I'll hit enter to finish it, and I will hit revolve. So it's that easy. Goblets, cups, things like that. So, I spent a lot of time showing you how to use curves and scaling curves and edge loops, and we did a lot of cylindrical work when I never did this one. And the reason for that is I really wanted you to get comfortable with moving and selecting and manipulating polygon objects. If you jump straight to this one, you don't really have any idea what edge flow is and how to control them and how the 3 edge rule applies. So now that you know all of that, you can apply your edge flow and edge control knowledge to this thing, and you can do that through the curve, since the curve is in control. So I could then insert knots to the curve to help sharpen up the goblet. I could work on my proportions and spacing by manipulating the points of the curve. It was really just wonderful. You have so many skills now. It makes curve modeling so much sweeter. Like if you wanted this to be more square right here, you could insert knots at this point into define a couple of curve points. You notice how it's hard for me to actually click on that curve because the surface is sitting right on top of it. Happens to me. What I can do, a couple things. I could actually hide it here, just totally hide all surfaces from the view. Or I could take that surface and put it on a layer by hitting this button right here with the blue sphere and just hitting this V button, so I can just quickly hide and show it. I prefer that, so I can just quickly hide and show it. There's also the option up here where I could go to the status line and say all objects off, and then only allow NURBS curves to be selected. But unfortunately, that doesn't change the fact that the radial menu still pops up. Even though I can't select this thing, the radial menu still comes up, which still allows me to select components. So that's pointless unless there's something really basic I'm missing. So the layer and hiding the object completely for the moment is more useful. So I could then select a curve point and say, between here and here, I would like to insert between those selections 3. Pop back to my goblet and notice how I have a lot more edge flow across the foot of the goblet, and now I have more points to do detailing. So now I can get a much more interesting looking foot. It's just wonderful, really. You wouldn't really know all of that edge flow control, I think, in my experience. Just hide that. If you hadn't already gone through all of this, so I can square this up a bit. Maybe drop that down. I won't waste your time with this, really. I mean, you can find a million tutorials out there on YouTube, probably, on how to make a goblet. I just wanted to show off Revolve. And I'll use Revolve to help make the body of the teapot. So instead of using my old methods of moving edge loops and inserting them, I'm not going to do that. I'm going to use the curves this time around, and I'm going to use the EP curve tool to trace the teapot. So I'm looking forward to doing that. Looking forward to showing that to you. Something else that you may want to know about this surface and this curve before I move on to loft and before I move on to extrude, that this surface, this goblet, ultimately won't be a surface for me. I don't intend to keep it this way. I intend to convert it to polygons so that I can then take advantage of all the other tools that I've learned how to use. So under the convert menu, right at the top is NURBS of polygons, and the option box is what you want to investigate, because the defaults may not be what you need. The easy mode, I think, of using this is to check mark control points, and when you use it that way, you get a goblet that's in faces. When you hit number 3, matches it edge for edge, isopalm for edge matchup. It's almost, well, it's nearly perfect. And then also notice that the curve is still in charge. So if I manipulate the curve, all of them are being manipulated because they're still all connected by input-output connections. Another good way to convert this, and I'll use this method on the teapot, is this general method here, where I can explicitly control the number of U, number of V divisions, and I could say, give me 48 by 48 or something like that. So now I can have a very, very, very dense polygon object, which is more useful for attaching things. So if I want to put some handles on this goblet, whereas this one wouldn't really accommodate having handles on it, but this one will. Or I could put little gem studs in it or something like that. So the more detailed one is more useful. So that's where this general method comes in handy. I don't really use count. I don't convert to triangles. Quads are better for the polygon modeling. I don't imagine needing to actually govern the exact count of polygons, unless I was maybe outputting to a game where you did a lot of modeling with surfaces and you wanted to control that. So general and control points and quads, those are the ones that I use. So on to the other ones, loft and extrude. Let's just hide these. Let's get a primitive circle for this example. Let's also get a primitive square so I can show you something with this one. The primitive square is made of 4 pieces and is held together by a group. So you could select one of its pieces and hit the up key on your keyboard, and that will grab its parent or select its group, which is the same as selecting everything. It's useful to know when you're working with these primitives, and it's also useful to know when you want to do something like a loft. So for example, if I duplicate this and move it up and then maybe hit Shift D, Control D for the duplicate, Shift D to make it repeat its transform. So I'll duplicate the circle and then Shift D it a couple times. So lofting is kind of like saying we're going to define the edge loops first and then we're going to create the surface. So when you hit loft, it generates a surface in the order that you selected your curves. So if I select this one, and then that one, and then that one, and then that one, I can loft between them. Alright, but here's the problem. You see how it twisted over on itself? That's because each square is 4 curves, so the loft doesn't know quite what order it is that you're trying to force them in. So it's my recommendation that you take those 4 and you attach them first. And I would use the connect feature so that it maintains its square look. If you use the blend feature, it's going to turn into a teardrop, and that might be useful. But in this case, I just want it to stay square. And now I can take that piece That's strange. I will have to come back to that, and I will figure out why it is that's happening, why it is that it isn't moving everything. Maybe I need to delete the history. Let me try that just really quickly to try not to waste your time. Delete the history. Yeah, that makes sense. Okay, because it was still connected to the other 2. That makes sense. So now I've got one closed curve, still square-like, and I can duplicate and shifty that a couple times, and now I have 4 curves. The loft should look really nice, and it does. So there's your correct way of getting a loft with the square primitive. Let's move on to extrusions. Well, I guess before I move on to extrusions, you should know that these are all, of course, can be manipulated and change its shape, and I'm sure you've already thought of some stuff by now. I'm going to use the loft when I make the spout for the teapot. Okay, let's just hide that stuff. Let's group and hide it. Delete these extras. Let's group the old stuff. Great. Great. And then finally extrusions. So I'll use the front view for this example and draw a CV curve, and I'll snap to the grid. So let's imagine this is some kind of tree trunk, something like that, and I want to grow something along that path, or at least model something along that path. This extrude tool in the option box has a number of different very, very, very useful settings. This is how you would create tubular, tube-like shapes that are animatable, also to grow something along the path. I'm not interested in showing you the animated version of growing something along the path, but to give you a tip in that direction is that you would use this partial feature, and I recommend just briefly looking up in the manual to get an idea of how to do that, but that's not what I intend to do right now. But it is nice to know that that's where it lives. So the way this works is that the circle is the called the profile, and the branch curve or trunk curve is going to be called the path. That's important because you've got 2 options here for profile and path, and where the result is going to live. So I want the result of this extrusion to live on the path. So this is not default. Excuse me. This is not default. At profile is default. So you want to make sure you check mark at path. Also, what's not default here is that the orientation of each isoparm that gets extruded and moved along this curve will follow the profile normal. So in other words, the up axis, the y-axis of the profile. So I want it to actually follow the path direction. That would be the tangent direction of the curve. So when I hit apply now, I get a curve, a surface that accurately matches the path. So what else you need to know is these two features here and here, rotation and scale. Another way to call rotation would be to call it twist, and another word for scale would be taper, because that is in fact what it does. So scale does do a kind of tapering from the start of the curve, from the start of the path to the end of the path, and rotation also has a twisting effect with no twist at the beginning of the path and the full 360-degree twist at the end of the path. And notice that when I twist it, I'm able to automatically force these insertion of edge loops, or isoparms in this case. Again, if you take a look at it with 0 degrees rotation, it needs very, very few isoparms to create this shape. And then when you enter 360 degrees rotation, it automatically adds about 8 or so isoparms to create this twisted shape. Another very interesting thing that we're going to take advantage of later is how we can twist around the path, and that's a simple matter of translating the profile away from the path. So if I translate this on the x-axis away from the path, it comes up with this warning, but you can ignore that. What happens is it starts to spiral around that curve, and more importantly, a couple other things start to happen. I can change the orientation of the profile, meaning rotate it, and that changes the overall volume of the extrusion. Notice how I can kind of flatten and pinch it and twist it, which also leads me to a point where I can change the shape of this by manipulating the CVs. So I could come in here and grab those and maybe those and scale them inward, changing the shape completely. So now I have more like a ribbon instead of a branch or a trunk. Very, very useful to know. And also the square primitive looks very neat when doing this as well. I recommend playing with that one. And another thing to note is that you can use absurd numbers for the rotation. So if I go back to the extrusion operator, let's say I want to have 6 times this rotation, so 360 times 6. So I'll highlight that number there in the input field, and I'll type in there times equals 6, and now I have 360 degrees times 6 equals 2,160. So if you don't know the math in your head quickly, you can just enter in a little equation there in the input field, and you can see what the result is. It's very interesting. And if the scale is still a value of 1, I can preserve the volume of my tube, and then also go back to the profile and start to manipulate the original make NURBS curve input. So I could edit the radius, and you can see how it propagates. I could also edit the sweep. So let's say I wanted it to be 180 degrees to give me a half pipe. So now I've got something entirely different. And let's say I wanted that to be rotated. I can't well, maybe I could rotate. Yeah, let's do that. Let's rotate on the Z. So now it's like, you know, a water slide or something. That's a crazy water slide. But, you know, something like that. And then let's say you wanted to thicken it. Well, that's when we would go to the convert option over here. We would select the surface, go to modify, convert NURBS to polygons option box. I'll use the control points, apply. And then if I want that to be thickened, I'll simply extrude it and do the local translate Z thing, And so now I've got a thickened version, and I'll hit number 3, so that's more organic. I could even hide the original surface, Control H, and now when I manipulate these two curves, I see the resultant polygons. Again, everything's linked up via the input-output connection. So again, if I want to change the radius of this polygon object, I can in real time see the result. Very, very handy. Let's say I want to reduce the number of rotations, so I'll say divide equal 2. So cut it in half. So now I have half the number of rotations. Incredibly useful. Let's say I want to just change the shape of the path. Go back here. Translate those. I want it to be taller, or I want it to be shorter. Or maybe select more control vertices at the same time and just shrink the whole thing down. Or maybe I want it to lean to the side and give me some kind of anti-gravity water slide or something. You get the idea. It's very interesting. All sorts of fun, complex, otherwise incredibly challenging to model and polygons, which are reasonably easy to solve with surfaces and curves. So very, very useful. So the fourth distant tool that I want to share with you in the surface menu is the boundary tool. And inside here we find a couple of options. We're going to use it in its default setting, so I'm going to make sure it's reset. And notice that it does have this partial option, which gives you the ability to animate it over the length of the curve. You can try that out for yourself. To get this started, we're going to draw from the top view to keep this very simple. I want to say that this technique, this tool, is incredibly useful for creating broad organic surfaces such as rolled steel that you might have for the body of a car, or even for clothing that drapes over the body and you need a way to patch in between a series of drawn out curves or a series of lines, if you think of it in terms of drawing. So what I'm going to do is draw out 4 curves clockwise fashion. I'm going to use CV curve tool to do that, and I'm going to snap to the grid. I'm going to make sure each one is 4 CVs per curve. Not for any other particular reason other than to keep this simple. And notice that I'm snapping the ends so that they're together. That makes this very easy. That makes this process much more straightforward. And I'll hit Y to repeat. Draw out my last one with 4 points. I'll hit enter. I'll select them in a clockwise fashion. Go to my surface menu and choose boundary. It has been patched. I'll hit number 5 and you can see the patch here. I can control the number of divisions on this patch by increasing the complexity of the curves on the boundaries of the patch. So I'm going to select each curve, or all of them all at once. I can do that. So let's filter all objects off and just filter on curves. Let's select all the curves at the same time. Go to my edit curves, insert knot option box. And let's make it reasonably complex. Let's make maybe 5 divisions, 5 knots between selections, so it'll evenly distribute divisions across. And if I turn on the wireframe, you can see the new divisions cast across my... And let's also turn off the grid so we can see the divisions. So there are the divisions on the surface. Let's bop back to perspective view and take a look at what we have. So basically I can control the organic flow of this and model it by editing the CVs of the curves. So I'm going to turn all objects on, select the surface, and for the moment I'm going to put it on its own layer and reference that layer so that it does not get in the way. So it's set to reference. I'm going to then filter on, I'm sorry, I don't have to filter at this point. I'm just going to select the curves. Oh yeah, let me filter on the NURBS CVs. So we'll go to the status line and turn on NURBS CVs. And I'll simply tag and with soft selections translate those to organically sculpt and shape this surface. So it is really quite a fantastic tool for creating reasonably complex, reasonably or very time consuming to create in polygons. Now what's really cool about this, and I want to share with you, is if I go back to top view, I could then extend to another patch. So let's say this is the hood of the car, or one side of the hull of the boat, or one patch of the pattern of clothing that I'm making for the character, and then I want to add the next section. That's simple enough by adding another series of curves. And I'll turn the grid back on for this. Snap. Something like that. And this time we'll just do something a little more playful. Something like that. And now with the curves being the only thing selectable, I'll select them clockwise, same direction, and I'll do a boundary patch on those. Now the complexity of this one is very much dependent on the new curves. So let's take those new curves and insert knots on those again. So we'll use the same stats on those. Turn off my grid again so I can see the wireframe. And what I want to do is just do a moderate amount of sculpting. Let's go back to my CVs. A little bit of sculpting, not on the surface, but on the curves. There we go. Oh yeah, right, of course. Make sure this surface is also on the same reference layer, so I'll right-click the layer being referenced, and I'll choose Add Selected Objects. And now I can freely select the CVs of the new curves, do a little bit of sculpting there. I just want to make some changes to this so that you get a feel for what we can do here. Alright, so that's enough. I'm not really trying to make anything specific. I'll then turn off my reference so that I can select these surfaces and run my conversion on it. Because you can imagine that ultimately this is not going to be a NURB surface. We're going to convert to polygons so that we can do all of our other practices with it, and I can control the complexity of it. So I'm going to go to Quads, General, and I'll do per surface number of isoparms, and maybe just increase it to maybe 20 by 20, something like that. And do the same thing on this guy. Okay, and we can hide the surfaces from the view. Extrude. Make sure this is reset. Turn off my soft selections and do a little bit of thickening to the surface. Okay, so there's a problem with the thickening, so instead of thickening, let's use local translate Z. Let's just push it up a little bit. Maybe even offset maybe 0.1, just to taper it in a bit so we can see the difference between the two. I'll select the next one, run the same thing on it, extrude, offset 0.1, local translate Z. Let's do a value of 0.2 and make sure local translate Z is also a value of 0.2. There, of course it's a negative number, so that means I have to flip the normals, so let's flip the normals. Okay, so this is the point that I wanted to get to, is that I can have two broad, organic surfaces like pieces of large steel from a Richard Serra sculpture, and they can be perfectly matched to each other, and I can still make modifications to it at their boundary. So if I filter out all objects and only select curves, let's put these things back on its own layer, reference those items, select only curves, curve, translate this curve, and just look how beautiful that is. I mean, we still have really wonderful control over these complex meshes, and look how it compresses so well here in the valleys, and so meaning modifying afterwards is very much possible, even on incredibly complex pieces. Great for clothing, great for parts and pieces when you're modeling the body of a car. I use this something similar to this when I make the saddle for the cat. And if you combine this with lofting, it's even more powerful. So it's just really quite nice and is worth the investigation. Alright, let's take maybe 5 or 10 minutes to look at the Edit NURBS menu. There's quite a few good tools in here as well. I'm not going to go through every single one of them, but several of them to give you some ideas on what you can do. So let's bring in a NURB surface to get this started, and let's give it a width of 10 or maybe 20, and give it about 10 divisions across. And let's give it some shape so that we can really take advantage of the power here. So let's select the control vertex and turn on soft selections, B for boy, on your keyboard, and just modulate that surface a little bit, perturb the surface a little bit, and something like that. That's good. And also bring in a NURB sphere and give that a larger radius, and just have something intersecting it, something to play with, and also rotate it to help show off what's really happening here. So maybe rotate it on the x-axis a little bit. So I'm going to go through a number of exercises between these different types of surfaces, and let's have a duplicate of this one sitting on the side, just in case I want it. Let's look at the top of the list, the duplicate NURBS patches. If you look at the radial menu, you'll see surface patch as an option, and it's like selecting a single polygon on a polygon object, except this is selecting a single patch, and that patch has a number, and we can do something to it, like duplicate it. So if we look at the option box, there's really not much here. And if you take a look at the channel box, you've got a couple of options there, such as first face UNV and face count UNV. So literally what this means is how many faces are you duplicating, and which index of the face are you duplicating. So is it index number 0, or is it number 1, 2, 3, 4, 5? Or we could move it this way, or we could move it this way. So really what you get, if you get a little creative with this, is you have the ability to, and if we turn on wireframe, make it a little easier to see, you have the ability to animate, really, which patch is active. At the moment, I can't think of a use for this, but seeing it will certainly jog my memory later on when I think I might need it. So let's delete that for now, so that you know what that does. Projecting a curve on the surface, that's really important. So we can project curves on surfaces from primitive curves, drawn curves, and from text shapes. So we can also project text on it. I think we should look at text because we haven't really done anything with it. So the text object, and in the option box we can create text curves. So let's make the word Maya. And if we just rotate that on the X, let's try 90 degrees, so it's pointing down, we can project that text onto the plane as characters. And actually, let's select the curves only. There we go. Not the groups. I don't want the groups. I just want the curves. And then select the plane, the grid, and then we'll go to the option box. In here, if I reset it, the default is active view. Active view means that the direction that you look at it, it will cast in that direction. So if I use it the way it is, notice that it cast those curves onto the surface according to the way I was looking at it, so kind of like a shadow. That's neat, but I don't need that right now. And surface normal is probably more what you're going to be using. I guess it all depends on what you're trying to achieve. So if you use surface normal, it'll take the normals of the surface, the direction of those, and cast the curves down in that direction. And you have now literally these curves that live on the surface as a part of that object. And we can use those projected curves to trim it. So let's take a look at that. So we can trim those letters and kind of cut away, which is what trim does. And trim is a little odd. Trim doesn't work unless a curve has already been projected on the surface, so we have that done. I'll choose trim, and you get this odd white interface. So basically what trim is asking you to do is to pick which parts do you want to keep. And you can see there are these dotted line grids. All you have to do is click once on the areas you want to keep. So let's say we want to keep where the characters are. So we want to keep the M, and notice it went solid, and then the A, those dotted lines went solid, the Y, and the A. And then when you hit enter to finish, and that's the trim. And so now you have that Maya text trimmed away, and it will render that way as well. So if we pull up the renderer, it will render that trimmed surface. So the surface still exists. It's still there. It's just that it's been hidden with the trim feature. And then trim can't be undone. The only way to undo a trim is to use the untrim surface. So you select the surface you want to untrim and then click on that, and it's gone. So it was a little tricky, but it works pretty good. Let's go to the sphere and to the surface again, and let's look at intersect surfaces. So, and the option box for that. So with intersect surfaces, you have a couple of options. Let's intersect both surfaces. First surface would be the first surface selected. So if they select the ground first and then the sphere, first surface would be the one projected onto. Let's do both. And if we use curve on surface, again, things like trim require curves on surface. So that's actually like a key word there to remember. Then you can trim it. Or you could actually generate a brand new curve in 3D space, but it won't work for the trim. You'd have to then project that 3D curve back onto the surface in order to have a curve on surface to use the trim. So let's use curve on surface in this scenario and apply it. And then select the plane and use trim, and then pick the part that I want to keep, and then hit enter. And then let's select the sphere. It also has been projected, or has a curve on surface. Let's use trim for that and pick the hemisphere that we want to keep, the one on the bottom, and then hit enter. And so we've just punched a hole into the surface, more or less. You can convert this to polygons and have this shape even with this cutaway, but it would require a large amount of polygons, and you can dictate that with the conversion on the count. So like I could say, all right, I don't want to have any more than 1,000. So if I choose 1,000 polygons, I can get something that's closely approximates the cuts that have happened there, and now I have my polygon object. And it tries its best to fit it in there. And another option is something that's more automatic, but not as clean in terms of quads. It's not as clean, and that would be general and 20 by 20. And when you apply that, what you get are these extra divisions in order to compensate for those curvatures. So it does preserve your curvature, and it makes these extra divisions, which visually could be interesting if that's something that you're trying to achieve. I kind of like it. Moving on to, let's use the intersect surface option again. Let's get another sphere and bring that in here. Okay, great. And let's rotate it just a bit. So let's do the intersect surface again, except this time let's actually create a 3D world object. And that one would be right here, this intersected curve, which we could then do other things to it, including projecting it to other surfaces. Booleans are kind of neat and clean with NURB surfaces. Certainly cleaner than they are with polygons, because what it does is it automatically trims pieces. So if I have, say, two toruses here, and I want them to connect like that, choose the intersection tool, for example. And if you take a look right down here in this area down here, notice there's instructions, and it says select one or more NURB surfaces to form the first object. Okay, so I got that. And then it says, or press enter to select the second object. Okay, so I press enter, and then it says select one or more NURB surfaces to form the second object. And I got that, and then press enter. And it brought it together in an intersection. So that that is the shape of where the two objects intersect. But I don't have to redo it because I still have the channel box option right here, so I could say union or subtract in order to get one or the other. And for the subtraction, it would be the selection order. It's very important. But for the union, selection order is irrelevant, and for the intersection, selection order is irrelevant. So there it is. And I believe, if I remember correctly, you can still translate one of the, maybe not. Let's see. No, okay, it's not a live connection, so that is exactly, the trim is the trim and it's done. Opening and closing surfaces, I think that's self-explanatory. Inserting isoparms, extending surfaces, offsetting surfaces, and reversing the surface direction. Those should all be self-explanatory. But in case they're not, I could select an arbitrary isoparm and choose insert isoparm. That will add a new edge right there with a whole new set of CVs. Extending the surface, let's take a look at this one for that example. Again, that should be self-explanatory. It should be end or start or both. Extend direction U, V, or both. And let's see here, and then hit apply. And you can grow it. Grow that patch. Or in one direction. Or only at the end. Okay? So hopefully that gives you the right idea of how this works. Okay, and then offsetting surfaces, again, should be self-explanatory, but in case it's not, let's use a cylinder for this example. I can choose offset surface, and it does exactly what it says. It creates a new one at a specific distance, particularly useful if we've already done a reasonable amount of work and you want to offset that surface a specific distance and to have some impression of a thickened surface or layers. The surface fillet, I did look into this one. I think this is pretty cool. So let's get another sphere for this example. So I can basically blend between this surface, this sphere. So let's do the circular fillet. And there it is. So it's a way of blending from one surface to another. That's what the fillet means. And the fillet has some settings in it, such as radius, secondary radius. So basically the inside ring, the outside ring, tolerance. And it's going to fillet in the direction of the surface normal. So if this was flipped, this would fillet in the opposite direction. Fillet freeform. Let's get a couple of grids for that to exhibit that. And frame those up. And let's give these guys a couple of divisions. Okay, so basically I can fillet freeform would be like an isoparm to an isoparm. Kind of like a loft. Something like that. And pretty handy, I suppose. Very, 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 very similar to a loft. And then there's this automatic, if we take a look at the option box for the fillet blend tool, there's this automatic stuff. And the way that one works is you select it, and again you get instructions down here. It says select surface curves from the left edge. So let's get those. So let's get that one. And then select surface, and then it says hit enter to do the right edge selection, so then get the right edge. And then hit enter, and it's going to have another fillet in between them. And this one's got a different set of tools in it, such as start and end for the right and left, and then reversals for right and left, which I think are pretty important. So you can actually animate this loft growing along that path. But that can be pretty useful in certain cases. So we can push and pull on start and end. And if we do like start, end, Yeah, so we can like fold it over on one end. Pretty neat, and you can have settings to turn off the automatic normal, or to turn it on for the automatic normal, or to flip normals, and that would be just whether or not these objects are twisted and such like that. Okay, so that gives you some idea of what these tools can do, and as I need them, I'll use them, and you should too, really, to help you solve getting back to the polygon problem. So you would use these to solve maybe some kind of blend or some kind of cut or some kind of text solution that you just simply couldn't do, but you thought, oh well, maybe I could solve it here, and then you can convert that back to polygons, and we'll be doing that several times if we haven't already.